into the panel. And so these issues will come up during that time. So let me just put up on the screen the 3 questions that we're going to be talking about. The format is going to be that we will have roughly 10 minutes per issue where we hear from the panel, maybe less than 10 minutes. And I've asked one member of the panel to lead off the discussion on each question. And then the other 2 panelists will join in, and maybe the moderator will be unable to restrain himself and add some comments as well. Anyway, here are the 3 questions. And it basically fits into where we just were in the discussion with Fiona. To what extent can neuroscience enter the lifelong learning for architects? So the first question I have is, to what extent do you think architects need to know about the brain, what's really inside the head, as distinct from results that may offer relevant data on human behavior that, even if they were based on brain studies, need not mention them? So, I mean, do you really need to know that there is a hippocampus in the head if you want to study navigation, for example? And Zach will lead us into the discussion of that issue. Then after we've talked about that for a while, Andrea will lead the discussion on, well, if you think architects do need to know about the brain, what do they need to know and how can they learn it? And I think, again, as we've gone through the 3 talks, we've seen occasions where things have come up where it would be nice to know a bit more to inform the discussion and benefit from it. And then finally, Fiona will resume where I cut her off and look at what issues raised by architecture might be the basis for studies of interest to basic neuroscience. That's my other half of the JFK perturbation. What is it that we can take back to neuroscientists in saying that perhaps you've been stuck in the lab too long? We as architects need to know a lot. How can you go from the terrible responsibility the architect has of designing all the details of a particular building to the luxury and the challenge of the neuroscientist in designing a specific experiment? Okay, so that's enough to set the stage. Let's at this stage call on Zach to lead us on the first question.
Lead us? That's quite a lot of responsibility. Yes. Did you have the question once again, just I guess for the audience?
To what extent do you think architects need to know about the brain as distinct from results that may offer relevant data on human behavior that, even if based on brain studies, need not mention them?
Right. Yeah. So I guess I'm going to borrow here what Lars Brorson-Fick, also a researcher, architect in neuroscience, would always tell me. He would start off with this quote from Winston Churchill, which is quite similar to what you had there, Michael, which is that first we shape the buildings and then the buildings shape us. And I think it's quite interesting because it sort of, creates this dichotomy. And there are those who wants to shape the buildings, the architects, and those who wants to understand how the buildings shape us, which is the researchers. Obviously, I'm way more in the latter one, right? I'm trying to understand how the impact affects us. And then we have another group of people who's trying to use that. Now, to what extent do the architects need to know about the brain? So I want to remind master builders versus architects, like contemporary architects. Master builders, what architects used to be structural engineer, mechanical, used to be contractor, urban planner, interior designer, used to be so many things. And now we have sort of, separated and distributed all the responsibility and the jobs and so on. So now the architect is the one who integrates things and come up with the creative ideas and so on. So this makes me question, why not think about also, adding this layer of the neuroscience, or I would say more psychology and research. So my experience lately has been that many studios reach out and they tell me that, oh yeah, they want to do a lot more with neuroscience and psychology and so on, but they just don't have the right profile, like to hire at the architectural studio who can follow these studies and interpret them and translate them. And it made me realize that there's going to be some kind of gap as our field is increasing in size and we are conducting more studies. who's actually going to translate all of these things and incorporate them if we don't already now do like Maria de Piedade, who's always talking with her students about these kinds of studies and really expanding their knowledge. And I think this is an important thing. So to me, I think yes, we do need to know more about the brain as architects. I think that this is an important thing. I think this is a necessary thing as things are developing. We don't have to be specialists, just like we're not specialists or structural engineers, but we have an idea, a qualified guess, and so on and so on. And I think that having the capacity to at least discuss some of these things is going to be a necessary feature of the future architects.
Okay, Zach, but you haven't really got into the guts of the question. So, for example, of 3 speakers here, you're the only one who talked about brain rhythms. So to focus your question, do you think architects need to know anything about brain rhythms? And if so, why?
Yes, I do think so. So I want to emphasize the fact that architects are only interested in the neuroscience because of the behavioral aspects of it. Neuroscience for the sake of neuroscience cannot be interesting for architects if there's no, let's say, impact of people on people. So if people are going to change the way they behave, then it's interesting. If I'm going to tell you that there is a peak over some kind of signal over the brain, the neuroscientist will go like, oh, that's nice, but the architect will tell you, so what? So there has to be like this kind of effect, right? And rhythms is exactly that. Rhythms have an effect. You can show that if you have increased rhythms over a certain area, you have improved memory, you are a better navigator, you can do all kinds of things. And this is converging evidence about that. So in my opinion, yes, the future architect needs to know sufficient about rhythms in the brain, enough to read some of these papers and just get a hold of them. Just understand some of the basics of it and maybe get inspired to work with it in some way.
Yeah. If I could just take this moment for a shameless ad, the point of my book, A Conversation Between Neuroscience and Architects, is precisely to try and get architects to the point where they have enough basic jargon to have a good conversation with a neuroscientist and vice versa. But I'd like to call on Fiona next. She showed us some nice diagrams of the brain and some brain imaging. So what do you reckon?
What do I reckon about how much? Well, it's the big question. I think that you've put it quite nicely, is how much, to kind of get a basic understanding of some of the jargon and some of the understanding of the brain to then understand what this might mean. And I think it is something that should be embedded into architectural education, but also similar to kind of Zach in terms of engaging with people that work in practice. I don't think it's the necessary point to go in and kind of hand over things to practice, but to kind of run workshops, go into firms that are interested, kind of discuss with them, share basic knowledge, kind of help them make an understanding of this, because it's really difficult, I think, to read a scientific paper when you first get to it, not just in terms of the jargon, but also just in terms of methods that have been applied in order to get to certain results. So this is one of the things that I think is important to take into account. It really matters how results have been achieved and how certain outcomes can be talked about, not just what's happened. Am I understanding your question correctly?
Well, I think actually reading neuroscience papers is probably too much to ask of architects. But okay, let me just formulate this and then come back at me. One of the words that Andrea stressed in terms of working out from the building was system. And I think that part of your work working in from the skull is that even if we don't remember the names of all these fancy brain regions, we can find different systems which link many areas, and their interaction provides the basis for our experience and our action. And so there's where you might be getting a message across, right?
I think you're right, definitely. It doesn't really matter exactly knowing the terminology and kind of where each brain region is, but kind of understanding in broader strokes what they're kind of more or less responsible for lack of a better way of putting it. I would think that it can be interesting to read an actual neuroscience paper here or there, but probably not kind of flying kind of in solo and going in cold. That could be quite daunting. But I think that the important thing is that you might then have conversations with people who are able to kind of unravel what's going on.
Right.
So,
I did once give a talk on how to read a neuroscience paper. Anyway, Andrea, last word for question 1.
Okay. I really think you mentioned like maybe it's not necessary to read scientific papers for architects, but I really think this could be an important step. So we won't, I don't know how to say the name of this game in English, but when you say something in the ear of someone and this person will keep like just saying a message in the ear, and then when you hear it in the end, it's something completely different from what the first person said. So I think if we are able as architects to read what you as a neuroscientist wrote, maybe we don't need so much translation in between, and this can help us better understand each other and maybe not idealize something like, as Fiona showed, like that design thing, saying like the ideal design, the perfect design that will like neuroarchitecture will bring. So that's my point of view.
Very nice. Frederick Bartlett wrote a classic book on remembering in 1932, and he talks about the telephone game, if that's what you want to call it, yes, where he shows how this changes. And Ernst Gombrich, in his writing on art and psychology, also picked up on this, the way in which we gather something of what another person draws for us or tells us, and then we fill in the details from there. So I think understanding that both at a psychological and a neurological level could be very important. But anyway, Andrea, you're still on the camera, because the next question is, if architects need to know about the brain, what do they need to know and how can they learn it? So apart from not spending too much time on the telephone, what do you suggest?
Okay, so, well, I of course, I will not list here like topics, but I think as was already mentioned, maybe a foundational knowledge would be interesting for both things. For us to understand how we process information about the space and how space therefore shapes our experience. And also so that we as architects can better understand the consequences of our designs. And I think neuroscience can help us with that. Maybe we won't have all the answers, but I think it can be very helpful. So I think the selection of content of what to learn from neuroscience should be based on allowing us to better understand the consequences of our choices. And also, Fiona had mentioned in a previous conversation, we had this expression, and I think it's really interesting. It should be based on how to help us improve our intuitions. So we're not trying to say something like, as a neuroscientist, I will tell you how to do your job, or I will tell you something new about architecture, but maybe I will help you to understand how your design will shape experiences and so on. So I think this idea of trying to improve architects' intuitions and knowledge about general knowledge about the brain, but also about specific knowledges, such as the brain when it's developing, or the brain when it's aging, on when it's diverse from the typical brain. I think this could be interesting. And still answering the what should be taught, I think the selection of content should be thought in a way to help architects read scientific papers, as I mentioned before, and as Fiona mentioned, to understand the methodologies and the limits, because this helps us not to accept like simplistic affirmations as truth, like, oh, it's from science and we should accept it, like how to create the design.
Thanks. Let me just mention one possibility. You started by talking about Donald Hebb, and he came up with a particular form of plasticity in the brain, which we now call Hebbian plasticity. And since then, we've come up with an understanding of how the brain does reinforcement learning from positive and negative feedback. We've come up with an understanding of supervised learning, how we learn from the specifics of our errors and so on. And meanwhile, there's been classification of different types of memory, like procedural memory. How do we learn a skill? Episodic memory. How do we recall something from the past? So I think these are ways in which we might invite the architect to learn more about learning and memory as being important to the experience of architecture. And then some will be invited to learn more about the details, and some will say, no, thank you, that was quite enough. Zach, can you jump in on anything specific about the brain you'd like architects to learn?
Well, again, I think I want to emphasize a few things. So I don't think that it's necessary for architects to know about the details. And that's why I made that distinction in the very beginning, because I think that some need to do that, right? Because there are some researchers like Andrea and Fiona who are interested in finding a way to understand this influence. But in order to do that, you need to know the details of the mechanisms of, well, the technical details, the neuroscientific details, the anatomical and so on and so on. But for architects to use them, it's not necessary. It's just
okay. Can I interrupt, because I want to rephrase the question then. There are really two distinct answers. You're just saying there are going to be some people whose job is to bridge between the details of neuroscience and architecture. But the question was really for architects who don't plan to get it responsible for the details. Are there concepts that will help them interact with the specialists, whether they're neuroscientists or interdisciplinarian? So what are the concepts you'd like when you have a conversation with an architect, and at least they've heard of the word neuron or brain? What more detailed concepts or other concepts would you like to have available for that conversation?
Yes, so this was my point. In the end, they don't need to know about the details. They want to understand what is the behavioral output. They go like, okay, sure.
No, sorry, Zach, I can't let you get away with this. You're saying they don't need to know anything about the brain. If all you want them to know is something about behavior. When people approach doors, if they're not wide enough, gosh, that's worrying. If it's wide, okay, they can go through. And therefore, the neuroscience doesn't matter a damn. You're interested in it, but you don't want architects to feel any responsibility to know anything about the actual brain. That's your conclusion, right?
No, I want them to know.
What do you want them to know about the actual brain rather than about behavior? It's a simple question.
No, I want them to know about both, but there are different concepts depending on different processes. So if you're looking to navigation, probably a good idea to know about hippocampus and like grid cells and so on. Sorry?
Keep it coming.
What's that?
More, please.
But this is exactly my point, Michael, right? Because they want to understand the bridge between behavior and neuroscience. I'm coming to it. They want to understand the bridge between neuroscience and behavior. And I totally understand that. Like, this is why, for me, the work of Fiona, for example, totally makes sense. She's looking at these kinds of things that are relating the behavior, what people are, the responses, the psychological responses, and the mapping to the brain. It's perfect. You need to know a few things about hippocampus, place cells, and so on. If you're looking into, for example, let's say extended cognition, I know that David was here somewhere. I saw him, Kirsch, yeah. So you need to know something about action and perception and like epistemic actions and so on. You just need to know about these things. So it depends on the topic. I don't know if I answered your question so satisfied.
Okay, Zach, on this note of positive chaos, we'll continue with Fiona. What if you're running a master's in architecture at the Bartlett School. What sort of things do you feel that the non-neuroscientists need to know in that program, if any?
I'm a bit torn right now because it does feel like what I'm going to say now might then immediately take us into the next question. I don't know.
That's quite all right.
Yeah.
So
we move
all
into
right. So Fiona is now going to answer her opinion on question B and then lead us into C, which is, once she's talked a bit about what architects should know about neuroscience, she's going to talk about what neuroscientists can gain in new lab questions for those for them who are interested in certain, as Zach would remind us, specific topics.
I mean, I think that Zach has already started something really interesting. And of course, I mean, the thing I didn't talk about today is the kind of question of wayfinding, question of spatial navigation and the spatial structures that enable it. And I think at the very least, even though some architects might find this quite boring, I think it is a really useful thing to know because it is there you know, in all architectural and urban environments that we are in, regardless of their function, questions of how we move around and how we navigate these spaces in different ways. Obviously, we have kind of different intents as we're moving through space. We have different backgrounds, but having a kind of a basic understanding of some of the processes that are at play can be really, really helpful, not least in relation to the way that architects do this kind of in an intuitive level, so that we can possibly refine this, and the decisions that we make in how we design wayfinding systems can be refined through our understanding of, for example, these spatial structures. And then obviously building up from that, we can get to other questions that might go into questions of how we light a space to, you know, kind of support the wayfinding, but also support other aspects of space, what kind of material qualities we might put into that space and how that relates to how we perceive that space, how we interact with it. So I think that that's where I'd kind of pick up the conversation there. And then going into the next question, in terms of the master specifically, and yes, David Kirsch is here. He just kind of popped up on my screen and then he was gone a bit. And this is something that I think he has something to say on about as well, because we've had conversations in the past in terms of issues raised by architecture that could be of interest. And it goes also back to, I think, one of the things that Veronica was asking just earlier on. You know, we can go to the to be expected questions that that conventional architecture might ask. But I think in terms of the masters, in terms of some of the interests that I have, it's about spaces that are more infused with technology, because technology is kind of more and more relevant in the built environment, whether it's directly built into the built environment or whether it's the technology that we use on an ongoing basis. These things aren't separate. They all together construct our experience of the world, the kind of system that we live in. And I think having a better understanding of how all of these different aspects come together, you know, whether it's things like smart buildings, where buildings might suddenly appear to us to have agency in some way or other, having an understanding of there. I think, Michael, obviously, you know, I'm also getting into areas that you're really interested in here in terms of how buildings might start moving around. And, you know, when I mentioned PASC and one of my slides, what I didn't get into there is that, you know, he already put forward this idea that an aesthetically potent environment might also respond to an inhabitant and, you know, kind of have a conversation. It's something that you've discussed in the past as well. I know that, you know, many people in cybernetics have, and in architecture, kind of, you know, mid to kind of late 20th century, this really became prominent. And the masters that I work on takes these things as a central theme in terms of kind of interaction that we have with the built environment, where it might not just be responsive or reactive, but also interactive, and take things into account that we do. And I think that that's something that in the 21st century neuroscience, these are architectural concerns, and neuroscience could really help with this understanding of physical environments in relation to virtual environments. You know, there are differences, but there are also similarities in the way that we might navigate them, the way that we might understand them and feel about them. And understanding these differences and these similarities here, I think, are really crucial points.
Okay, if I can just insert another brief commercial. One of the interesting things about the hippocampus is it's not only involved in navigation, it's been implicated in episodic memory and also in imagination. Yeah. And so in the last chapter of my book, I try to bring those three themes together in thinking about how the brain might work with many systems besides the hippocampus in the design process. And the problem, of course, is that I find again and again that the answers that I need to fill in the details of this aren't in the neuroscience literature yet. So that's another answer. So Zach, what are you, from your experience, do you think do you regard your work as experiments in neuroscience, it's sort of in basic neuroscience, or do you see them as part of the conversation? And what might you ask a real neuroscientist, if you forgive the expression, to tell you about, let's say, how EEG works or other aspects?
Yeah, so for me, this was a clearly a neuroscientific question, but the research question, which I think is more important when in this context, was clearly inspired by phenomenology and philosophy, psychology, and this cross-section that I think is extremely important to understand as well in our field of neuroscience and architecture. I just want to point out that someone mentioned something in the very early part of this session, that environmental psychologists are, why are we not reading each other's work? And I want to just say that she was completely right. You know, I just came back from the environmental psychologist, and they are doing amazing work that I'm pretty sure everyone here would find amazing and very interesting. So I would put my own work in the field of neuroscience. It's inspired by philosophy, psychology, and trying to understand the role of affordances. I'm not sure exactly where this, what you were hoping to get out of this question. But I do see
Okay,
that
Zach,
Samuel,
thank you. I just want to remind you that on one of my earlier slides, when I said all the things that people in ANF are interested in, environmental psychology was on that slide. And the purpose of this session was to say, yes, given these multitude of interests, how do we fix neuroscience? Anyway, let me give Andrea the last word on this before we open up the Q&A.
Okay, so I think maybe there are two pathways to think about this. So first, architects trying to understand in a more universal way our relationship with the environment. So for instance, what's the role of light or natural light, or how artificial light can disrupt sleep, or how wayfinding is important as a cognitive stimuli. And this is connected to the hippocampus, which is important for episodic memory, but also connected, it's one of the most sensitive areas maybe of our brain for aging and stress. So it's important for architects to understand more general concepts, but also I think architects can ask questions to neuroscientists about the specificities of different user groups. So, and not just different user groups, but different user groups using the space in different ways. So I don't know, a person, I don't know, a young child or an older person or someone with neurodiversity learning or healing or playing or I don't know, working. So I think those two lines combined work well together.
Good, and I think that fits well with Zach's concerns too, so that's great. So we're now going to have about 15 minutes for the question and answer. And the idea of this is not going back to the details of the earlier talks, but this general theme. And so to keep it manageable, when I recognize somebody, I'd like them to tell us not only what their question is, but to choose one person to respond to it. And that way we can work through a reasonable number of questions in the little time that remains. So Marta, you seem to be the first person.
Yes, thank you so much. And thank you for this panel. I think it's such an interesting topic to try to think about education. I am lucky enough and privileged that I do teach students of architecture on topics of neuroscience. And normally they give me, both in university and in other kind of outside classes, they give me very short time. And normally what I get to show is like a little like inspirational thing about how much, emotions affect the body and our health. So if we build places that make us feel good and that we perceive pleasantly, this is going to support our nervous system and our health. And I feel that that giving architects some inspirational idea coming from neuroscience is powerful enough, because then that makes their work more meaningful, and thinking, whoa, what I'm doing is really, influencing how people are going to feel and develop and be healthy in their bodies. So I guess my question to Fiona is, which concepts of neuroscience you think are the most inspirational to teach kind of even to the general public or to architects and architecture schools? And before I give you the word, thank you so much. The other thing I wanted to share is that the few things that I found actually useful that architects like knowing and that might influence how they program space is knowing the theory on affordances, or that we perceive the world through what it affords us to do, because then people start thinking more about like, oh, like multi-postural environments in like, pleasant materialities and like this type of affordance relationships. And also I love teaching on the polyvagal theory, because then people understand how sensitive our nervous systems are and what how different nervous systems are, because I think we tend to think we're all like ourselves, but we don't understand how many people have suffered trauma and other have other circumstances that affect how they perceive the world and how safe they feel. And I think that affects a lot in programming too, in creating spaces of privacy and things like that. So yeah, these are the main two things that.
Okay, thank you. Thank you very much. We have the honor of David Kirsch, the president of ANFA, with us, a distinguished cognitive scientist, but not without opinions on neuroscience. So David, take it away.
Thank you, Michael. Of course, you have to introduce me like that so generously. So it's a question for you, Michael. I hope you don't mind. And here it is. What we're looking for often we look for correlational theories. They're kind of theories, right? So Fiona was working with, she identified a class of, I won't call them architectural atmospheres, but she had identified a bunch of the stimuli that she liked and thought they were, broadly speaking, in equivalence classes or classifiable in some way. There are many other things too, but she put them in groups. So those are her stimuli classes. And then she's measuring some kind of responses. They could have been behavioral, but they could have been at the brain. They could have been something else. And so we have a correlational theory. Some people might not yet look in the brain and do exactly what Fiona did. And they would come up with certain kinds of, say, affect measures or any bunch of things that they wanted to, let's say, measure. And so we have these kinds of correlational theories, and they can be predictive. Then you have a correlational theory that, let's say we did the first one without going to the brain. We could also do the correlational theory that has this based on this. And we say, well, what's happening in the brain when that particular thing is happening? That's predictive of what the brain is going to do when we have this classification up higher. And then you say, okay, I don't see an explanation here. Now, could I have an explanatory theory, please? Now, explanatory theories are often going to be either explanatory in psychology with some kind of model of some sort, or some kind of computational thing, and then might even be computational neuroscience. So nobody said a word about computational theories. And you know, in the old days, we used to put that before we put going in and, you know, poking around down there. So what's your view, Michael?
Well, I think it's a measure of my incredible restraint, which everybody has noticed today, that I did not ask a speaker to speak on computational neuroscience, which is my thing. But let me pick up on it. What I said earlier was that what I'm interested in is the search for mechanisms. How do we do it? And if I'm not relating that to the brain, that's cognitive neuroscience. And I've introduced a format called schema theory, where I sort of say, these are the different processes that are needed. Here's how these processes interact. And between them, they'll yield the behavior. And then when we go to the brain, we try to say, well, how do different parts of the brain execute those schemas? And in some cases, and this goes back to work we did in the 70s, in some cases, once we look at brain lesions, for example, we find that it can't be true, the original model that we made at a purely cognitive level, because, well, we started with frogs. And the idea that we thought, well, frogs have a schema for approach and a schema for avoidance. And then we made a lesion, which should have stopped the frog from responding to anything that was scary, right? The avoidance response. But in fact, it would snap at it as if it were harmless rather than. So that led us to new theories. And then that led us to work with anatomists and neurophysiologists to get into more detail. So the point is then you can work at a behavioral level, where just here are some input-output correlations. You can work at the next level of cognitive science thing where you say, actually, if we chart some of the interactions, then we may get a more detailed ability to make predictions. So we're not just summarizing what has been seen, we're saying because we have an idea of what interacts in the head, forget the brain so far, then we can make predictions about how people will behave in a novel environment. Oh, now that might be useful to the architect. You can't commission a post-occupancy evaluation of a building before you build it. So if you can make some predictions about how people will respond to different features, that's good. And then finally, the brain gets into even further details. But as everyone has said, that then has to percolate up into things at the behavioral level. This is what you can do to get certain effects. So I think that's probably more than enough. So Maud has been patiently waiting for a while to talk. So Maud, take it away. Turn on your microphone. Thank you.
Hi. It's more about timing and depth that I have a question. So the way I see it, it's like if a bathroom remodeler or there's a bathroom designer decides to design a bathroom, then he might go ahead with his creativity or her creativity, and then the plumber will come along and say, well, you can't do that because then this might happen, right? And so I feel like it's kind of the same debate here, right? When does neuroscience come into architecture? And is it a risk assessment? And how much a designer need to know about plumbing? Or does he just need to know that this can or cannot be done, right? So what's the depth that we need to go into here? Is it just a yes or no? Is it just this option versus this option? Is it a risk assessment? And when in the process does it come? Because we all know that architects are designers, they're creatives. We don't want anybody coming in and telling them what to do, but we kind of want to have that risk assessment.
Thanks. So before I turn this over, because I'd like each panelist to answer that, because it's a really crucial question. But first, in response to what you said about bathroom design, I just want to observe that if you want to design a really good bathroom, you need a client who is flush. No, nobody gets it. Oh, well, never mind. That's the trouble with the English language. Okay, so why don't we start with Zach?
You want to start with Zach? So can you just try to put because I think there was a lot of layers, just put the question in one sentence just to be short.
Yeah, so my question was, at what moment in the process does the neuroscientist come in and give advice to the architect? Is it before the creative process or after the creative process as a risk assessment? And the second question is in terms of depth. I mean, I have my idea on it, but I would want to know yours. Is it the same level of depth that, for example, a designer would know about plumbing, where the plumber would come in and say, well, you can't do that because there's something here that prevents you from building the sink here. And that's it. You don't need to know about the detailed, mechanics of the plumbing. You just need to know that this can or cannot be done. I feel like it would be the same scenario here for neuroscience, where you don't need exactly to know which neuron is firing. You just need to know that when you design it that way, with that level of complexity, that might be not pleasing to the eye for certain types of people or whatnot.
Exactly. I completely agree. So in my opinion, my personal opinion is that we're nowhere near getting to the point of level of detail to understand that kind of influence and interaction. We're very far away. But I do think that there are different purposes, right? You can use neuroscientific literature to get inspired. I think that, for example, Michael Arbib's book is a good place to start to get inspiration and to understand better what are they doing in neuroscience and how can it inspire my creative process. But it's another thing to try to assess, because assessing the building is a completely different aim, I guess, right? So to get to the level to actually get a proper and concise assessment of the building, and I guess that can be on many levels, right? Because there's like the mental health aspect, the well-being, psychological aspects, cognitive processes, can you enhance certain things, and so on and so on. These are very, very complicated questions. And again, this is a personal thing. So for me, I'm an experimentalist. For me, it's about making first the experiments, and then we can start talking. But for me, speculating about these things on the literature as it is right now we're not there, in my opinion. But I like how you're thinking about it as how to implement it directly into the architect studio. I think that's a fantastic way of thinking, the approach.
Thank you. Andrea, what do you think?
I really like the way Maud puts the question about the plumber and makes this kind of comparison. But I think the chance of an architect having a plumber to help is higher than the chance of an architect looking for help with a neuroscientist. So I think that's one of the reasons why I think it's important for architects to learn at least some basics about it, because this maybe will help them to look for help, because they will know it's complex and they are not able maybe to understand the complexity alone. So I think it's a very well put question, because this is an important point. And I think the neuroscientist can be helpful in different moments. So I think it's kind of a continuous collaboration throughout the project. So in the beginning, it can help maybe they can help maybe direct the architect's attention to specific points that maybe we wouldn't pay attention to if we were not talking to them. And maybe during the entire project, we can keep coming and going and making questions like, what do you think of this? And I think this is the richest way in which we can work together.
Okay, thank you. So Fiona, could you close out the answer to Maud?
Okay, I think I'd probably repeat a lot of what Zach and Andrea have said.
All
But
right,
I
the new
think the
stuff.
thing that I would like to emphasize is what Andrea's just said, is that you need to have some basic understanding to begin with to be able to ask the right questions, because it's not just about then intervening. And I like the plumbing example, because I think that architects should certainly know a lot more about plumbing, at least here, because there's a lot of fixing going on and kind of then trying to go in and improve things that could have been done a lot better from the outset. And I think that the same thing could apply here, where if there is some understanding, we can ask the right questions and then kind of having an ongoing exchange. I mean, I think Zach was also getting at this in one of the points he made earlier, is that it's not just a case of, you know, I think that neuroscience and kind of neuroscientific expertise should be part of a contemporary design process. And I wouldn't see why they can't kind of become actual architecture experts in that sense as well. I mean, you know, you might have a neuroscientist working in an architecture firm. You might organize way more workshops and interactions, starting, you know, with architectural education and then keeping that going. I think it is
Okay.
about ongoing conversation.
Terrific, thank you.
Problem.
So we have time for just one last question from Bob Condia. And Bob, preferably could you address it to one of the panel?
Yes, it'll end up with Fiona. First note is that all expertise, architects included, see through the language, so to speak, of how they think, right? So a plumber sees through plumbing, an architect sees through architecture. My friend Michael Arbib sees through neuroscience. So this expertise is how you would see something. And to inform architects to a higher level of neuroscientific expertise, albeit the idea that biology might be the real basis of an architectural enterprise rather than maybe finance. So Fiona, what we did is we stole something of your paper. We had students, I say we, Elizabeth, had students design corridors, and those corridors then were shared with one another, and they made the valence quadrants as a way of thinking about these different corridors that each of them had done, and each had done a variation on individual themes. So it's really kind of a nice exercise for them. It took about a week. And then, well, what do they get out of it? What are they left with? Well, for one thing, they're thinking now that there's a difference between emotions and feelings, and that they have both qualities in positive and negative sense, and it has a valence in that, and it has a strength. And that we can see that maybe a quadrant, we might, when we're talking to clients and programming, we might begin to talk to them about the difference between emotions and feelings. And as we become, and my friend Zach has pointed this out many times, as we become more expert in the subconscious aspects of space, this is really an expertise, because no one knows this, but we could know this. So we could talk to them about their feelings, but we can't talk to them about their emotions, but we can demonstrate these emotions through the work. There, Michael.
Thank you. Fiona, last word?
I mean, I'm just curious. I'd like to see what these students have been up to and have a conversation with them. That sounds
well, on
fabulous.
Okay, well, let's stop on this very positive note. It's been fantastic to hear from these three brilliant speakers. It's been great to see the diversity of questions that have been raised and the beginnings of answers. And I think the hope that I share with our three speakers is that this is the beginning of an enriched conversation on the issues that we've broached today. So with that, I say farewell and turn the baton back to Tatiana.